All right, hello and welcome to FACT's webinar, Building Soil Health Through Animal Agriculture. Our guest presenter is Dr. Janel Ohletz. I'm Samantha Gatton, FACT's Humane Farming Program Associate, and I will be moderating this session. Thank you for joining us. And it's really embarrassing that I don't know how to pronounce Janel's last name because I've known her for years. So it's really embarrassing. So sorry, Janel. All right. Here we go. Before we dive right in, let me take a minute or two to do a few quick introductions. Food Animal Concerns Trust, or FACT, is a national nonprofit organization that is headquartered in Illinois. We work to ensure that all food-producing animals are raised in a humane and healthy manner. We accomplish this by supporting humane farmers, promoting policies that make foods from animals safe and healthy to eat, and helping consumers make informed food choices. My colleague Larissa and I run FACT's Humane Farming Program, which works with livestock and poultry farmers across the country. We offer grants, scholarships, training courses, mentorships, and of course, webinars on a variety of absolutely fascinating topics. We are currently accepting applications for our Fund to Farmer grants through tomorrow at midnight. So if you haven't done it yet, get your acting gear. You're running out of time. Please visit our website at foodanimalconcerns.trust.org to learn more about our farmer services. So I am actually very excited to, this webinar has been planned for a very long time. I'm very excited to introduce Dr. Janel Louise Ohletz. She grew up in rural New Hampshire on a small family farm with a market garden and a barn animals of every genre. Janel was a USDA National Needs Fellow in the Crop and Soil Science Department at NC State University here in North Carolina, where she earned her PhD in soil science. Her research focused on nutrient management in high-yielding field corn using machine learning and remote sensing technology to gain a better understanding of dynamics in soil fertility. She has an MS in agricultural science and a BS in sustainable agriculture and food systems from the University of New Hampshire. She's pretty impressive. She is deeply committed to working towards a more sustainable and equitable ecosystem through the use of regenerative and climate mitigating strategies. Janel is also a classically trained chef, and prior to earning her degrees, she worked in the hospitality industry for 20 years. She believes in making an impact by being part of the conversation, whether that be to advocate for changes in our food and agricultural systems or presenting at sustainable and organic focused conferences with her message that good food starts by building from the ground up. So without further ado, I will turn the floor over to Janel so that she may begin her presentation. Janel, take it away, and I'm going to unshare for you.
Okay, thank you. Okay. All right, here we go. I hope everyone can hear me. I'm going to, before I do all of that, I want to stop sharing my video. If I can do it from here. All right, there. That way you don't see my talking head, but you just see the slides, which I think is certainly more important. So today I'm going to present a little bit about soil health. Now it's a very, very broad topic. There are 5 disciplines of soil science. And so to just get into it, I want to really lay down the basics for you. And then perhaps there'll be a time in the future, or you can always email me with questions that we can dig a little deeper. The puns around here, I'm sorry, I'm going to apologize now. There are a lot, and soil is just so easy. So today I'm going to talk about first soil health versus regenerative agriculture. I know regenerative agriculture is very much in the news right now, and a lot of people are talking about it. And so I want to kind of clear up a little bit of the details of what that means and the difference between the two. Why is it soil health and regenerative agriculture the term of the day, essentially? And then we'll get into the soil basics, which is very important in understanding those before you can really begin to start to build the soil health. And then some principles and practices to begin to do that in your location. So first, what is soil health? Well, the USDA is actually defined it, which is a good thing, because without a definition, everyone can just come up with all sorts of things of what they think. So it really is the continued capacity of soil to function as a vital living ecosystem. That's important that we talk about it as a living ecosystem that sustains plants, animals, and humans. Although I do have a bit of a problem with the whole fact that we left humans outside of animals, because in my book, if we just lumped them all together, we would probably maybe from the get-go not have so many problems where we are right now. So regenerative agriculture, on the other hand, is not an actual defined term. And so until it's defined, it's going to be a very broad base of all sorts of things. And so to kind of set that point out and really kind of demonstrate that, so there was a research paper that was done looking at all of what is out there on the internet, research papers and everything, and kind of came up with kind of a meta-analysis, as you were, of regenerative agriculture. And so first we have one definition, and there were hundreds and hundreds of different definitions, but I picked out 3 of them. A system of farming principles and practices that increases biodiversity, enriches soils, improves watersheds, and enhances ecosystem services. This is very much focused on the soil health, and this would be very much in line with likely most people in agriculture would be thinking what regenerative agriculture is. However, we have a different definition, a long-term holistic design that attempts to grow as much food using as few resources as possible in a way that revitalizes the soil rather than depleting it, while offering a solution to carbon sequestration. So this one takes a little bit further down the line and then says, okay, not only do we want to ensure that our agriculture practices are benefiting society and the ecosystem, but we also want to use it as a solution and begin to draw down carbon. And then lastly, we have this very different definition, a form of enterprise that incorporates a community of people engaged in civil labor to produce and consume the food and the land, landscape, and amenity that they collectively decide to grow. It's a very different, more sociological definition. And so many people, especially if you're very much into the agriculture realm, wouldn't think of this as necessarily a definition of regenerative agriculture, but yet it is used when talking about what they mean by regenerative agriculture. So I really just put this point to let you know that when someone's talking about regenerative agriculture, it is very important to get them to define what they mean by it before having more of an in-depth discussion about it, because they may be in a completely different realm of what they think it is. And of course, there are many other terms that kind of deal in this realm of, either organic farming, regenerative farming, soil health, and all things that have to do with benefiting perhaps or revitalizing our ecosystem services, that is soil, and how we go about agriculture in maybe a more climate positive way. All of these terms and many more are out there, and it can often be very confusing. But really, why now? Why is it so much in the news and everyone's talking about it? And there's even the federal government is now finally funding things that are researching regenerative agriculture. Well, we have some problems with our planet right now, the climate, and we have extreme floods, extreme droughts, weather systems that have more energy, major wildfires, all of those things, and all of that is linked to the climate, and that climate is highly affected about how we go about producing things and ensuring that we are not causing more of the problem, but we're going to try to help become a solution. And so soil has been looked to as a solution because much of the carbon on the planet is either stored in the soil or it's stored in the oceans. And so here, this picture really demonstrates the difference between our conventional agriculture system and our regenerative agriculture system. And why now, as I discussed, really because when we look out at a field, we really want to see the one on the right-hand side and not the one on the left-hand side, because that would lead to soil erosion, topsoil loss in a rainstorm, as well as it would make it just very difficult to have animals out there on that to have anything to eat. So what is the role of soil in all this? And where do we start regardless of whether you are in agriculture, you are just a person at home with just a backyard. It really is going to start with looking at what we're doing with our waste and where all of that goes, but also how we curate the land that is under our feet, because topsoil is so important for life on the planet. So now I'm going to dig into the basics of soil. So soil is the living skin of the earth. So it is just this little tiny bit that goes all the way around that sustains life on earth with a little bit of added rainfall. And when we lose it, it takes hundreds and hundreds of years to just produce an inch of topsoil. And so inches of topsoil can be easily lost very quickly with erosion, with wind erosion, as well as rain or water erosion. It is what sustains most terrestrial plant life. And it is a three-dimensional body. It is not just the flat surface that we walk on, but it actually goes down below, from below the feet. And it differs from place to place. And I think this is one of the things, a concept that is the hardest to wrap your head around when you think about soil. It's like, well, it's just dirt. Well, actually, dirt's a thing that you get under your fingernails, on your pants when you're out there kneeling in it, but it is not soil. So we don't want to treat soil like dirt. We want to treat it to ensure that we can have it be the healthiest as possible, because when it is healthy, then it provides those ecosystem services that then allow many more things to thrive. But what I mean with different from place to place, soil in Wisconsin or Minnesota is going to be very different from in Florida. And the organic matter that you can build up is going to depend, it's going to differ very, very much so from those two. They could have the same soil type, but yet because of many other factors, those soils are going to act completely different. And so it is really important to understand what type of soil you have on your property, and is going to differ. If you take a field, you look at a rectangular field, in actuality, if you were to look at a soil map, it's not rectangular. It's going to be very different. So even though that from the surface, it's all flat and it looks all the same, actually underneath, it's not. As you can even see from these images here, and I'm going to hope you can see my cursor. Here you can see these kind of formation in this upper one on the right-hand side. This is very different from this depth here to the subsoil and down here to this depth. And here, this is part of the reason why is all of these different topography and aspect ratio of the sun and all of that. So what forms soils, in fact, are 5 key major buckets. You have climate, so that's the temperature. That also has to do with the precipitation, how much rainfall is there, how much sunlight and hits that ground, which would then warm that soil. So it's not just the air temperature, but it's also the sunlight hitting it. So if it's a northern facing slope versus the southern facing slope, if it's on a hill, those are going to be different soils. And then seasonality also, whether you have something like, well, we have in New England, where I grew up, we have 5 seasons, and we have the regular 4 seasons, then we have mud season, which happens around March when the ground hasn't completely thawed, but the top layer has, and we get rain, and then you drive on it and it just turns into a muddy mess. Then you have organisms, and these are all of the living things, not just above the ground, but then within the soil themselves. They actually help to form that soil via them eating the organic matter and helping to reduce the size of that and biodegrading that, as well as, say, a mole or a vole that digs a hole in there. Then the worms that make little, what we call macropores. That actually also helps to form the soil because it allows water to get down in there and other organic matter. And that changes the biogeochemistry of the soil. And so the relief, so this is really talking about the slope, how steep a slope is it, what direction that slope faces, and then just the topography of the land in general. And then we have parent material. What was the main starting point from that, whether it's a Was it a volcanic eruption? Was it wind-blown soil coming from a mountain that's being worn way far away? So you have the winds coming over the Rocky Mountains, slowly picking up these little particles of soil and then dropping them into the Midwestern area. Well, that's called loess, and that's actually it got there from wind. And then you have the glacial till, so glaciers that kind of ran across during the Ice Age. They went across Canada and down into the upper Midwest. And then at the end of that glacier, you have this kind of, when it started to melt, little bits of soil particles would fall. And so that's another way that parent material got deposited there. And so that is another thing that, depending on the type of parent material you have, is going to play a lot into the type of soil chemistry you have, and what you can grow and what you can't grow on there, or what would thrive or not. And then time. Really, all of this is time is the biggest factor, in that these things happen very slowly, but that it's constantly working and forming the soil. As long as we're not losing it, we can form soil within that place. And so a good acronym to remember is CLORCT, which is the C for climate, L for location instead of the relief, and then you have parent material and time. So the biggest thing, if you don't remember a single thing today about soil other than this, it's that soil is dynamic. It is always changing, constantly. If I took a soil test today, and then I went out again tomorrow and took a soil test in the very same location, and I sent them to the lab, they would likely be different. So it has to do with the moisture. If it rained yesterday and then now it has another 24 hours to drain some of that water out, then it is going to change the amount of nutrients that are available and some of the properties that are within there, because the amount of water changes the chemistry within the soil very quickly. And that actually has to do with the microbial community that's within the soil. Those microbes are constantly being influenced by the amount of moisture and the temperature within the soil. And then they, in turn, are breaking down organic matter, or they're breaking down some of the soil particles within there, the clay particles, and maybe a fungal hyphae, which is basically like a root of the fungus. And that actually has an enzyme, and it can actually break down rock. And so that all of those things are happening within that soil profile, which is known, this little block here is known as a pedon. It's basically a three-dimensional section of soil. And within there are constant factors being acting, and that is controlled by all of those soil forming factors. So what does a healthy soil look like? Well, when we take a bucket of soil and we were to look at it and we'd say, well, is it healthy or not? Biggest thing to understand is that within that 100% of that shovelful of soil, about 45%, give or take, it would be upwards to 50%, is kind of the solid mass of it. The other half of it is going to be made up of air space, as well as that air space or air pockets or void being filled with water. So a healthy soil has half of it being material and the other half being kind of a void, and that void or space is a healthy one would have about half of it being water and the other half being air. Roots need to breathe, as well as the organisms that are within the soil need to breathe. And so we need to have that gas down there. Some of it's going to be oxygen, some carbon dioxide, nitrogen gas, and some other gases that would be down there. And that is going to change constantly depending on the size of the air pocket and the organisms. But it is vitally important that we have both water and air in there. And then the other half is generally about 45% minerals, and then the other is going to be organic matter. But that also depends on where you're located and how healthy the soil is. We aim for 5% organic matter, but in the South, where it's warm much of the year, it's really hard to build 5% organic matter unless you're in a wetland area. And much of that has to do with the fact that if it's flooded all the time, the organisms are not doing aerobic digestion of that organic matter, and they're not releasing that. So it's really a location based, because in New Hampshire, my mother has 10% organic matter. Well, it's cold for half the year. Right now, the organisms aren't doing any decomposition at all. They're frozen. And so right now, that organic matter is just sitting there. And so it is being broken down for less of the time of the year, versus in the southern regions where it's warmer, there's just that much more time for the microbial community to break down the organic matter and it to be released. So the mineral component of that is three main particles that make up what we call soil, other than the organic matter. And that is sand, and it has a specific measurement. It's anything that's less than 2 millimeters in diameter, but in slightly larger than 0.05 millimeters. And then silt is, again, smaller than that. And then clay is anything less than 0.002 millimeters. So it's very, very, very small, not even as small as this little dot here. If I put the size of it there compared to the other ones, you wouldn't be able to see it. So this is not to scale. But to demonstrate why this is important, what is your makeup of soil where you are, how much sand and silt and clay really changes the properties of how that soil is going to act. If you think about the beach, which is mostly sand, and then you think about clay, where, like my backyard, where I can make bricks of it, there's areas where it's 100% clay or nearly. Those two things are extremely different, and actually has to do with the size of those particles and how they kind of behave together. If you think about a room filled with beach balls, which would be representing sand, there's a lot of space in between there. But then I could put some basketballs in amongst those beach balls. Those would represent silt. And it would fill in all the voids of the sand, but I wouldn't need to do anything by removing any of the beach balls. I could put basketballs in amongst all of that. And then I could take golf balls and stick in amongst that. And I haven't changed the volume at all, but I'm continuing adding more surface area in there. And that surface area plays a huge part in the ability to hold and retain water as well as nutrients. And so when we talk about surface area, here's a good way to look at it, is I have this volume. It's just a 1 millimeter cubed volume of coarse sand on the left. And then we break it down into smaller and smaller particles as we get medium sand, and we would get closer to a silt. And then we look at clay. In the same volume, I can get 1,000 million particles of clay in the same volume that I can get that coarse sand. Now you think about the clay as a three-dimensional thing, and it has surface. And around all of those 1,000 million particles is going to allow it to have water stuck to it, compared to just that one coarse sand particle only has that one bit of 6 millimeters squared amount of total surface area, compared to 6,000 millimeters squared in clay. And so what that means is clay is going to hold on to water a lot more. This is why it's so sticky and wet. And sand, I mean, you see the waves on an ocean, comes in onto the beach and it immediately disappears. So when you're looking at trying to grow plants to either eat for yourself or feed to your animals, the type of soil that you have is going to affect how you manage your water and your plants, because it's very different in the amount of water that can be held there. And maybe we want to hold a lot of water, but if it's 100% clay, then it could be too much water. And if it rains a lot, it could get flooded very quickly, and the water is not going to drain through there very well. There's another way to kind of look at what we call bulk density, or looking at soil, and not looking at sand, silt, and clay now, but just looking at, say, all the way on the left-hand side, you have a very dense soil and very little bit of porosity. And so that could come from a lot of compaction, nothing there at all growing. And so the water is just not going to drain through there at all. And then this is a study that was done. It's called the Jena experiment. It was done in Jena University in Germany. They actually looked at the diversity of plant life and how that affected the porosity of the soil. So they had 60 species all the way on the left hand or on the right hand side that really, because of the different types of roots and how deep those roots went and the different kind of structure of those roots as they grow, completely influenced both the bulk density, reduced it. So bulk density is just how much of something you can put in a volume. So if you were to take a shovelful of that soil there, that would be light and fluffy, versus the one that is all the way to the left, which would be very dense and heavy. So it does make a difference, not only with what we're working with as a parent material, and you have your location, you can't do much to change sand, silt, and clay. It is what it is. However, what this study shows is that you can influence it greatly by what you plant and how you treat that soil, and help to change those properties in a favorable way, even if you can't, add a whole truckload of sand to your clay soil and help it that way. So when we talk about soil properties, there's three main kind of buckets that these properties go in. There's the physical properties. That's the structure of the soil and how it aggregates. And aggregation is basically, if you think about it, if you take a shovel full of soil, and how the little clods and clumps come together, that's aggregation. Surface sealing is actually what happens when it rains on a soil surface that, especially when it's really clayey, but if it has no organic matter or nothing growing on it, and you can see that when you get those puddles, and then when they dry out, they crack. That's called surface sealing. And that's really bad, because then what happens is, it rains, but the water never goes down into the soil. Kind of runs off and leads to erosion. Then you have compaction, and that's if you're driving over wet soil, it's a really, really bad thing to do. That then affects the properties of the soil, because if it's very compact, it means the water won't go through. Porosity is just, again, it's almost the opposite of compactions. More porous soils allows more water to go through. And of course, the water movement and availability of the water. And then we have pH, which is a measure of the acidity. And then the soluble salts, which kind of goes along with that. Sodium, certain areas of the country have a high amount of sodium within their soil. If you're using lots of fertilizer, that can lead to that. Nutrient holding capacity. Sands aren't good for holding nutrients, but yet clays generally have a charge, so they'll hold on to a lot of nutrients. And then the availability of nutrients. A lot of that actually has to do with not just the amount of clay you have within that, but it also has to do with the amount of organic matter and the microbial life within the soil. And that comes down to that biological component, the large organisms and small organisms. And we have the microorganisms, and then we have the roots that play into that. So they're helping to feed those organisms, because they exude carbohydrates that actually feed those microorganisms, and the microorganisms hang around the roots to get a little bit of sugar from the plants. And then the biological activity, which is basically a measure of all of those organisms within the soil and what they're doing. And organic matter is the lifeblood of the organisms within the soil. So what do we mean by organic matter when we talk about that? I really mean the living, the dead, and the very dead, because the organic matter breaks down, it's feeding the organisms, they do that, they release the nutrients, which then get taken back up by the living roots of a plant, and then that continues to cycle through. And who's doing it is all of this, what we call the soil food web. And so we have these organic residues down here in the bottom left-hand corner that feed these actinomycetes, which are kind of like mushrooms, but not really. We can thank the actinomycetes for giving us all sorts of antibiotics. The fungal community, which helps to break that down, and the bacteria. So the real small guys actually are doing most of the breaking down of the organic residues, and then they feed the next layer of organisms. And then those organisms feed the next layer, larger organisms. And so this is this web of organisms that require another organism to help it have life. So when we think about keeping a living soil, which is going to make that soil extremely healthy and happy, organic matter is the bottom part of that. Without organic matter or things that are breaking down, these organisms don't have anything to eat. So how does it work when we have organisms? So we have this at the top, and this is just going to walk you through this diagram. We have the crop, which we're growing, and whether that's forage on a field or trees and with the leaves falling down, or a backyard garden, you have that plant life that's living there, the residues that are hopefully left behind, or at least as much as we can. Then the soil organisms, soil biota is just a fancy word for microorganisms, or little critters that live in the soil. They need oxygen. They bring that oxygen in and they help decompose that organic matter. And when they decompose that, it becomes humus. And this is not hummus, that's good with pita chips, but humic matter is actually really broken down, like in your compost, when it's really well broken down, that's like humic matter. And then we have this immobilization, and basically just what that means is the organisms have eaten it and they've taken it into their bodies themselves. It's now become part of them. And then when they excrete things, that is the proteins and polysaccharides. And basically that is a nice sticky substance that helps hold the soil together, and it becomes both part of the soil structure. But then as they release those nutrients and these organisms die and decompose and they're helped decayed by another organism, then we have mineralization. Mineralization is just the opposite of immobilization. Things are immobilized, they're held in, they're locked up. And then when they're mineralized, they're allowed to be released into the soil, and then they can be taken up by the plants. And so those nutrients are then either taken up by some other soil biota, or they are taken up by the living roots of the plant. And this continues to cycle through. And why is it really important to have living plants on the landscape? Well, here is a infiltration demonstration that we had done at the Cooperative Extension when I worked there. We have these 5 different little locations here that represent different types of management practices. So we have all the way to the right is basically till all the time, totally beaten up. Then we have this is basically like a no-till. Then we have a lawn. Then we have a grass that is mob grazed or rotationally grazed, and this is continuously grazed. And then what we have here is the buckets in the front represent what ran off when the rain was falling. And as you can see here, well, geez, most of the water ran off of the bucket of the tilled all the time, because that means no water actually went down through. And you can see the bucket on the bottom represents how much water actually went through into the soil. So what would have been stored in the soil. And so it's really important how we treat our above ground, or how we manage our soil system, plays an enormous part in actually how much water will either leave when we get a nice rainstorm, or actually be held and stored within the soil. And you can see here with this, regardless of the type of soil that we have, even if you have sand, which isn't notorious for having a lot of nutrient holding capacity, and certainly water doesn't get held there very well at all because it drains out very quickly. If you add organic matter, you in fact actually increase the amount of water that can be held, even if you had a beach sand. And even better, if you have silty clay loam, you can really hold it, can hold 4 inches of water, which if you go a couple of weeks without a rainstorm can be make a huge difference. So I want to talk a little bit about the type of soil you have, and then when you have a rainstorm, and in a visual way of looking at how the type of soil, which down here on the bottom of this graph, we have sand on the left-hand side and clay on the right-hand side, and then the percent of soil water. And what this demonstrates is what would be available for your plants depending on the type of soil that you have. And so we're looking at a forage and a grassland or something, depending on the type of soil that you have under those plants, really is going to make a huge difference in how much water is going to be available for what you have. And so when thinking about it that way, if you had a lot of clay, we have hygroscopic water. Basically, that is the water that's stuck to the particles, it's stuck on the surfaces, and it's completely unavailable to the plants. We have this terms called cohesion and adhesion. There are forces that cause that water molecule to be stuck to the surface of that clay or any of that sand as well, or even like when you wash your car and you see the little drops of water. That is cohesion and adhesion at work. So that's unavailable. So you could have 25% soil water in clay and it's completely unavailable to your plants. Conversely, in sand, it's 5%, it's unavailable. Then we have gravity water. That's the stuff that drains off very, very quickly. It's not held around at all. It won't be there for the plants. And anything above that is, if it doesn't drain, it's going to be flooded conditions. So we have this available water. And you can see that in sand, you have a very limited difference between when you have no water available for the plants and you're in flooded conditions. Versus in clay, you can 35% above that, you're going to be flooded conditions. So really the sand or the silt loam in the middle is kind of ideal because it gives you this 20% difference between whether you're going to have wilted plants or whether they're going to be flooded. So you can't change, again, you can't change the type of soil you have, but if you were to add a little bit of organic matter, you can actually influence this sand and this clay to get properties that are a little bit more like a silt loam. Then looking at nutrient uptake, which is really important, even though you are mostly animal-focused group, but those animals do eat plants. And so really important to understand how those plants can access the nutrients within the soil. So you have mobile nutrients and immobile nutrients. The mobile nutrients just means they can move through the soil pretty quickly. They can move over to the roots as the roots take them up, but they can also be leached very easily as well. So if you're fertilizing something and you put on nitrate and it rains, that nitrate is mostly lost within the soil. It leaches very quickly. Versus the immobile nutrients, which are the ones that generally move slower within the soil. And some of them move so slowly, like phosphorus, that actually the root has to intercept it in order to actually take it up. Unless you have a very active fungal community and the fungi actually make a relationship with the root of the plant, and it is able to get the phosphorus for the plant in exchange for a little bit of carbohydrate from the plant. And so those symbiotic relationships are vitally important for the nutrient exchange. And all of those nutrients are made available because of the organisms that are living within the soil. If you do not have any microbial activity within your soil's dead. And essentially, you don't have the nutrients available easily for the plants to take up. And you would have to supply everything, even micronutrients for that. And so now I want to kind of switch gears a little bit. I've given you a very basic overview of soil properties. And I'll just talk about some of the practices that can help lead to improving the health of the soil. But remember, location matters. So what works in New Hampshire is not going to work in Southern California. It's not going to work the same. You have to take all of these things with a grain of, rather salt, we'll say grain of sand. You really have to think about where you are and how that is going to affect what you're going to put in practice. How is that going to work in the location where you are? And so we have integrated pest management. And I'm not just talking about insects. I'm also talking about weeds as well. We want to think about integrated pest management. Certainly a presentation, you could do a whole hour on that, is try to reduce what allows that thing you don't want to survive, whether that be getting rid of the pest itself or reducing the thing that makes it grow best. And so if this is the case of weeds, well, don't give it the stuff that's going to allow it to grow very well and outcompete something else. Also, rotation is very important. Proper rotation when you're looking at grazing animals and moving them through a field properly, not allowing them on the just continuously grazing in an area, is going to be really important for improving the health of the soil. Managing the water, which can be extremely important when you're talking about where does the water sit, and not just water management of how the water drains through your land, how it moves across the land, how you have your paths for things around for your animals, but also where do you put that water? And do you have a solid surface so that when the animals are going to continually walk over there, that area around that water would be very compacted. So thinking about that, it's like, well, where's the best place to put that? If you're going to have a muddy season, which is going to happen, thinking about the best place to manage where you put that is also going to affect how you have healthy soil around that area. And also reducing the soil disturbance as much as possible. Sometimes you need to rejuvenate a field, really important. Doing that in a time that is appropriate with some guidance from your local extension agent or soil and water districts can really be beneficial in perhaps doing a no-till drill instead of just tilling up the whole field. Keeping it covered, keep living roots as best possible on the land as you can. Really important for keeping that soil alive is feeding the organisms, because you really are, when you're growing a plant, and especially when you're growing a field of grass, you are not a grass farmer, you're a microbe farmer. If you keep the microbes happy, the soil will be happy and your plants will be doing much better and they'll grow much better. And increase organic matter, that really comes from keeping it covered and keeping the organic matter or dead leaves and things like that, put them back on the ground as much as possible, because that will actually help you manage your nutrients, because whatever that plant took up, it's part of its body. And if you allow that to stay back on the land and decompose, all those nutrients go right back in and it gets recycled. So look, really, it's important to know where you are before you can figure out where you're going. So take a soil test. Cooperative Extension is a great place to get some guidance on how to take that test. And then take a systems approach. Look at balancing the productivity, because that's important for a livelihood. How you take care of the land, that's the stewardship. Ensuring that you can make a profit off this land. And profitability is not about, like, let's say, yield. It's about balancing the inputs and the outlay, right? If you're looking at a crop, you're going to spend a whole bunch of money on fertilizers, but if you can reduce the amount of money spent on fertilizer, you don't necessarily have to have an increased yield and you would have an increased profit. And then also quality of life. Thinking about adding that into your approach is really important as well. And when we talk about a systems approach, this is what it really looks like. It's very messy. Not going to spend a lot of time on this, but there are a lot of things involved in what it means to balance out trying to bring about soil health on an agriculture setting. And think about closing the loop on your farm. And there's all sorts of different ways, and many of you are probably already doing the carbon farming, your grass farmers, you looking at sequestration, you're doing proper rotation. But I often show this slide to a lot of other people when we're talking sustainable agriculture. And this is kind of how our traditional agriculture works. You know, we grow the grain that we feed the animal, and then its manure feeds the organisms and they feed the microbes, but we still have this extra external input because we have to have the tractor and all the fertilizer that grows the corn. What in fact, we got rid of the tractor and we grow grass and we graze those animals on the field instead, then therefore we have closed the loop and we keep all of those nutrients within that farm. And I know someone had mentioned they wanted to hear a little bit about silvopasture. The USDA's Forestry Service is a great place to get some research. I have a link that I will put in the chat later that about a little bit more about silvopasture, but really it is about grazing animals underneath the canopy of trees. And there's a lot of benefits to this because you have the shade, which helps keep your animals cool and happier, but also helps to allow some more moisture retention, as it were, because there's less heat on the ground, so you have less evaporation from that. But it is important to get some guidance on this, rotate properly. You need to think about fencing, the source of water. So when you're thinking about getting into silvopasture, certainly get some guidance from either the Cooperative Extension or the Forestry Service. Also, some universities have some research into this in the best way to kind of go about it, because there are certain types of forages that grow well under the shade of trees and some that don't. So before just jumping right in, get a little bit of helping hand would be important. And then integrating in multi-species into the system, and it's not just doing necessarily one or the other, and integrating in those animals within a cropping system also, I think, is really another way to add that soil health. So when we have animals and cropping systems together, you really help to bring back the soil health a lot faster. But it's important to think about the animals that you have on that land and thinking about the type of diet that they eat, because generally your beef animals or your bovine or cows, they eat mostly grass. They'll munch on a few forbs and they'll eat it mostly, well, a few woody plants, but not much. Versus the goat really loves woody plants. You can look at the camellias from my goats, they certainly ate them. And then a little bit of grass and a little bit of forbs. And so these two would work well in a system where you kind of had a little bit of both types of plants, whether you had some broadleaf plants, some grass, you have some woody plants. If you bring in both cows, maybe sheep and goats all in together, they're all going to have a different preference for what they like to eat. And someone had asked a little bit about parasites and things of that nature. This plant right here, Sericea lespedeza, is actually really a good plant for helping with parasites, but also ensuring that you are grazing the animals properly, one after the other, and how you graze them can also really affect that parasite management. But it is also important to think about the height of the plants. And when you move those animals, looking at the animals, looking at the forage itself, and when is the time to move them off, because they've eaten that to a point where now those plants might not be able to actually thrive back. And you'd have to set that field out of rotation longer if you leave the animals on there for too long a period of time. This slide really demonstrates the reason why you want to rotate them off sooner than perhaps most people traditionally do, is because of the root system. You can see these two on the left, you have the height of the plant and how deep the roots go. And then the different types of plants actually have very different root systems. So having a variety of different types of plants also can be beneficial, because those roots have very different activity within the soil and can bring up all sorts of nutrients. So variety is the spice of life. It's very important to think of it that way. So lastly, manure management. It is important to manage the manure, but then also know the source of the manure if you're bringing a manure from outside. There are certain herbicides there of the picolinic type. Grazon is one that lots of people like to use on their fields. But if, let's say, you have horses and you get some hay from someone who's used Grazon, that actual herbicide will pass through the animal and still be active for up to 4 years. And so there's been lots of people who've gotten composted manure from someone, and then they put it on their plants and they die. And so it's really important to ensure that you're managing the manures properly and knowing where's the source of that manure, or where's the source of the grass and how that was treated, because that can pass through. And lastly, it's just reducing soil disturbance. You want to look for the stuff on the left. That's the way a field should look, whether green, and then animals within there, not the one on the right-hand side, which bare soil leads to losses of carbon dioxide and water, both. And then that reduces the health of the soil. And then again, variety is the spice of life. I can find a nice slide that had a bunch of little animals on it. But really thinking about variety, both in plants, for what you have for your animals to graze on, and how you treat that, really does help the soil health extremely, more than probably anything else. And it also helps the ecology of the above ground as well. So with that, and I know I rushed through lots of stuff, I want to take questions so that way I can address anything that I didn't quite touch on in the talk. Thank you.
Thank you, Janelle. That was amazing. And while I'm gonna let everybody sort of have a few minutes to think, I'm actually going to put a poll up. But I have to figure out where I am first. Hold on a second. Okay. So I've got the poll up right now. Oh, I don't. I do now. Now I have the follow-up. And if you guys would like to answer that, that would be fantastic. I'm going to go ahead and share my screen, and then we can get back to the questions. And let me see if that worked. There we go. Anyway, so if you have, if you, Larissa, do you want to start while I get myself together here?
Sure. Yeah. And just a note to folks, there's been a couple questions in the chat. A recording of the presentation and the slides. I'm going to be sending that out to everyone. It's also on our website. If you scroll way up, I'll post it again, the landing page for this webinar. But thank you, Janelle. That was really, really wonderful. Great breakdown of all the fundamentals. And yeah, it was super interesting for being so technical in that regard. When we do have some questions that we're going to try to, we might go over by a couple minutes, but we're going to try to be respectful of everyone's time tonight. Janelle, is it okay if we go till maybe about 5:35 your time? Or
Oh yeah, that's fine.
That's okay.
Yeah.
Okay.
Yeah. I could talk about this all day, as you can tell. It's really hard to narrow it down. It's like, oh, I got to add all this because I saw all those questions. I'm like, ooh.
Yeah, exactly. Yeah, some inspiration for.
Yeah.
So going back, so people have added some questions. We'll try to get to them. Otherwise, yes, someone did also ask for your email, Janelle, and I will be sending out a follow-up email. If it's okay, I will CC you on it. If you, or I can provide it to folks otherwise as well, if that's okay.
I'll
with
put
you.
it in the chat.
All right, she's she's public with it. Okay. So question from Tess is, how may I maximize results when can't easily cover seeds due to rocky soil? Sorry,
Well, there is one thing you can do, depending on where you are, is a thing called frost seeding. So you can actually seed when you get a frost, kind of at the end of the season. So, you know, you see how the ground kind of opens up a little bit. You can put the seeds down, and then after the frost, then it kind of closes down over the seeds. You want to do it right at the end. Sometimes the timing can be a little bit difficult, but if you put those seeds out right after that happens and the ground is kind of opened up, that can help if you have rocky ground.
All right, thank you. And so this question is, or I guess, well, it is a question, but it's also a comment from Craig. There seems to be a disagreement on how fast soil can be built. Is it possible to rebuild soil faster than hundreds of years through the building of soil organic matter and the soil sponge? So
there's a difference between improving soil and building soil. Improving soil by adding the soil organic matter, yes, you can certainly help what is there. But the actual soil, being those mineral components of sand, silt, and clay, take hundreds of years. But you can improve the little bit of soil that you have there. And then the microorganisms will begin to help turn that up and maybe bring up a little bit of the subsoil to mix in with the topsoil. And help that, but actually building soil itself, by the pure definition of it, does take hundreds of years.
Thank you.
Next question is from Jane, and it has to do with how long soil can sit after being collected and being sent for analysis.
Good question. That depends on the type of analysis. If you're going to send it like to the our NCDA, North Carolina Department of Agriculture, who's just going to do a basic chemical analysis of it, they do not measure biological activity. So in that case, it could sit around for quite a while. That's okay. They're going to dry it down, and then they're going to analyze it, grind it up and analyze it. But if you want to look at biological activity, in that case, it's very important to get that off to the lab as fast as possible and ask the lab how they would like it submitted. Maybe they want it to be cold in a plastic bag so that you don't lose the microbes in there, because if the microbes die, then you're not measuring your biological activity as much. Unless they do a DNA test.
Very helpful. Thank you.
Thank you. Yeah, so I actually know when Alicia asked this question. It's when you had the slide up with the different particle sizes for the sand, the soil, what was it, sand, clay, and what was the other one?
Silt.
Thank you. And so Alicia wants to know, well, what is loam then?
Loam is the perfect balance between about 30%, 35% sand, silt, and clay. So loam is the ideal soil. So loam is just when everything's in balance and you have the right amount of organic matter.
Thank you.
Question about when B12, where is the B12 available? Do you remember when that was asked, Sam? It was after that slide that you just talked about, but.
Oh, like B12 is in the vitamin?
Yeah.
Well, it is one of the vitamins that is, you can find it in fungal properties. So things like, well, you say like if you're trying to get B12, if you're a vegan and you need B12 because it's vitally important, you can only get it from living things. You can get it from fungus, you can get it from bees, honey, but then again, if you're a vegan, you're not going to do that. And then like the outside of potatoes, and the reason why you eat the skin, because the microorganisms that are living there. So technically you're eating animals, but you're eating very little ones.
Love it. I love it.
All right. So Kimberly actually wants to know if your recommendation on a website, but I'm actually just I will copy and paste that and send it to you, Janelle. And then we'll go to another question. Okay, so I'm going to ignore that one as well, because that one, oh, okay. Why do many not speak about rabbit manure benefits in compost?
Maybe because not everybody has rabbits or is easily available to get, but it is really good. Doesn't burn plants. Very, very nice for the nutrient availability. But I think it's just, I do know that rabbits are, especially meat rabbits, are becoming more popular again. So I think you'll see more of that research, but it takes a long time for things that act like on the fringe people are doing for it to actually matriculate into the university setting where people then do research on it. But there is a couple of people that NC State actually has meat rabbit sessions they've done. So I think it'll become a little bit more aware to the general public.
Okay, thank you.
And I just pasted Janelle's email back in the chat for those that were looking for it. So I will send that one. Okay, question. Are there any particular challenges in soil stewardship associated with farm scale? So we're talking commodity crop operations versus, oh, Sam, you just, okay.
Oh, did I just get rid of it?
Oh, no, it's there. I just had to scroll back up. So, you know, the on one side, the commodity crop versus small.
I was trying to be so organized.
Yeah.
Look at me.
So
small, diversified, yeah.
Scale does matter. However, the infiltration demo that I did, the legs of the person that you saw standing there, Nathan Lauder, he's the soil health specialist for the East Coast. He's the USDA soil health specialist. And he does 6,000 acres and does that with the soil health premise. It is really those practices of keeping it covered, using cover crops, using multiple different species, and then he does cattle and he grazes them and moves them along. So you can use these principles on all sorts of scales. It just depends on slowly going about learning that. There's a learning curve. There's another gentleman who does no-till cotton and all sorts of things, and he has been doing cover crops for about 15 years or so. An older gentleman whose only regret was he didn't start sooner, and he's 6,000 acres. It can be done on a large scale. It's easier to do on a small scale. It's how you do it on the different scales. You can't like silage tarp 6,000 acres, but there are ways to do a cover crop and then get rid of that cover crop through roller crimpers and other things. There is a learning curve to it. Expect that you're not going to hit it 100% out of the gate, but trying is better than just sitting there doing nothing. So a little bit at a time will certainly benefit the soil.
Let me just ask a quick follow-up, because this actually was another question specifically about cover crops. Do you have any resources that you could point folks to for ideas about what goes best with what animals and for different benefits?
Well, a lot of that depends on, yeah, the animal type, and, you know, some things are okay for some animals, you know, depends on like the nitrogen that can be, you know, can cause bloat at certain times of the year. So really important, get guidance from cooperative extension agent to help you there with that. But also there is a really good, kind of looks like a periodic table for cover crops. I will get the link. It's on ARS, USDA ARS. If you Google USDA ARS and cover crops, it'll come up, but I can get that and send it off to you.
All right, thank you. This person asks, you mentioned that soil composition changes frequently. So if we are trying to decide on amendments, how often should we do soil testing? Thanks so much.
So you should always soil test at least once a year until you really got your stuff going. And I'm still test every year, always at the same time. So if you do it and with the same conditions, so make a few notes of how what was the condition, did it rain right before, or was it dry, things like that. And then try to sample around that same time of the year with similar conditions. Then you would be comparing at least an apple to an apple, even if it's a Macintosh to a Red Delicious, but it's close, because then you're going to see a trend. But if you were to do 1 year in the fall and 1 year in the spring, you're going to have completely different results when it comes to phosphorus availability with magnesium, zinc, all of those things. Is huge differences. And also depends on when you fertilize. Test before you add fertilizer, not after you add it. That's also going to make a big difference. But generally keep it the same every year. Make good notes, and then ask a cooperative extension agent to help interpret the results if you need a little help with that.
Awesome. So Sam, maybe you and I can take one more each and then we'll wrap up. Okay. So question, or I guess the scenario is, my soil is very acidic and I've been adding lime every other year. I've been told too much lime can cause other problems with increased salt. What do you recommend?
Well, it's really not the increased salt, but when you get it the other direction, now you got another problem. You have too much lime in there. So now it's like the acidity is so low. Now you have calcific soil, and now you have to then add sulfur to bring the pH back. And the reason actually has to do with the availability of nutrients. pH affects that greatly. Certain nutrients are more available at certain pHs. And so the reason why the sweet spot is generally between 5.8 and 6.8 for plants is because of that is the most of those nutrients are mostly available right at that. Some are less available in the high acid and some are less available in the low acid, things like that. But right there is that sweet spot for plants. Anything below 5.5, you will have what's called aluminum toxicity. And so it is, even if you don't want to spend a lot on lime, if you're looking at forage and you want to grow grass, you have to get that pH above 5.5. Because when it's below that acid, the aluminum actually burns the tips of the roots, and those roots just can't get down into the soil. Lime does not move quickly through the soil. So if you have an area that, let's say, is brand new to forage, it's never been farmed before, and you take a pH and it's 4.8, you're going to have to put lime on that and till that lime down into the soil. And disturb that for that one time, because that lime will sit there in that top inch of soil, and it's going to take years and years and years for that to slowly go down. It doesn't go down through the soil profile very quickly at all. But if you're at 5.4, add some lime. The organisms will help kind of mix that around a little bit. And so it's really important to get the pH. Before anything else, get your pH right. And then a lot of other things will fall into place.
So I'm going to ask the last question. I really hate that we couldn't get to everybody's. I've just been scrolling through them, and there's some really great questions. But I'm actually going to ask Marilyn's question, which is, did you talk about pigs and I missed it? Can they pasture with other animals? And we did not talk about pigs. Or then, Marilyn, this is the reason why I chose your question.
I love pigs.
The answer to this too. Can they pasture with other animals and using their manure? And I guess
I think they can pasture with other animals depending on their behavior and all that and what they do. Like, there's certain pigs that are better at forage and some that will root up the whole field and you won't have anything for the other animals to graze. So different I mean, like kunas, I think, do a little bit more of like eating the grass rather than rooting it all up. But, you know, the longer you leave a pig out there, they're certainly going to disturb all of that ground. Do not use pig's manure on anything that you will be consuming or a human will be consuming. Pigs are so closely related to humans, and their parasites are the same. And so you could end up inadvertently with parasites that you got from the pigs. So you can use it for lots of other things on perennial gardens or whatever else if you're not going to eat it. But do not put it on your garden as or put pigs in an area that you're going to say, I'm going to let them till up and I'm going to grow my vegetables on there. And it takes many years for some of those parasites. They actually can kind of hibernate in there for a long time. So even just leaving a couple years wouldn't necessarily be a good idea.
Eeks. I didn't know that.
Me.
Good to know.
Yeah. I feel like, Sam, there's probably several more webinars we could do with Janel.
No kidding,
Janel.
right? No kidding.
I would be happy to chat.
All right, we'll talk.
Dish in the dirt is what I do.
You're a dirt nerd. That's what you are. All right, so actually I have a few housekeeping items to share before we sign off today. A recording of this webinar and the slides will be available soon. Larissa has already mentioned that in the chat. These documents will be archived on our website and Larissa will also email them to you, she said, later on today. I think she's a superstar. We also have some other good webinars coming up this winter, some really good ones that I'm super excited about this winter and spring. Larissa will send links to all of our upcoming webinars and other opportunities for farmers and ranchers in her follow-up email as well. Again, our Fund a Farmer grants close tomorrow at midnight, so get your acting gear if you're planning on applying. If you've already done it, good for you. A sincere thank you to Janel. It's been an honor and a pleasure to have you with us. It always is. I always enjoy our discussions. I'd also like to give a special shout out to my colleague Larissa for all of her help behind the scenes and telling me what to do and what not to do. And finally, I would like to thank everyone out there in the audience for their interest and attention. I hope you had a good experience today and we will stay in touch and connect again soon. Enjoy the rest of your day. Goodbye for now.
Bye, everyone. Thank you.
How do I close it, Larissa? All right. There we go.